Hello, this is Lab 4 Oscillations in Physics 2211. Here's a brief overview. First, we're going to go over the introduction, then the physics involved, then the observed motion, then the computational model, and then finally the results, and then some key takeaways. Introduction. Purpose. The purpose of this lab is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the attached spring. Also to show that we are able to predict motion using our fundamental principles. Results preview. The computational and observed motions were very similar, with the only likely source of error being due to inaccuracies with the tracker software. Physics involved. Fundamental principles and equations. The important equations are period of oscillation and the spring force equation. We utilize these equations in the lab to calculate K and L0 to be used in our computational model. Observed motion. Tracker. So here are some of the values that we retrieved from the tracker setup and program. First, we knew initially that the mass of the weight was 0.402 kilograms. We know that the spring constant is 6.869 newtons per meter due to the calculations using the aforementioned formulas. The oscillation period was 1.52 seconds, which was determined using the Y column, and L0 was also calculated using the aforementioned equations and was calculated to be 0.126 meters. Computational model. So here's some of the data that we use for the computational model. I changed delta T, I changed the spring constant and the relaxed length of the spring. I edited several lines to calculate L hat, and S. And then I changed several lines of code in the while loop. I changed the amount of time in the while loop, and I defined all of the energies using all of the relevant physics principles to this lab. Results. Model comparison. The observed motion is in black and the computational motion is in red. As you can see, the computational motion follows very closely with the observed motion, and the only likely error is due to minor errors with the tracker process. So as you can see, the observed and computational motion is both oscillating, which can be seen due to the kind of like sine curve, cosine curve shape, that sort of shape in graph. Key takeaways. What does it mean? So the first what does it mean question was, is the energy principle satisfied? And the energy principle is satisfied because there is no work done on the system by the surroundings, so the system is isolated and the change in energy will be zero. The total change in energy will remain constant throughout the experiment. What does it mean too? The oscillation period for X was calculated by finding the initial position when time equals 0, and then the time when it returned to that initial position, making a full loop. And that time was calculated to be 1.61 seconds for X and 1.52 seconds for Y. This means that the motion of the object in 2D will be an ellipse and not a perfect circle shape because they have different oscillation periods. And that the shape of the ellipse will change over time. Thank you.